Alright, so let's look at some example problems for completing the square. Let's look at number 1. So number 1 is going to be y is equal to x squared plus 6 minus 6. Or sorry, plus 6x minus 6. So in this case, we're going to do what's called completing the square. So essentially what that is let's say by completing the square, it's going to be written as x plus or minus some c squared breaks down into ax squared plus bx plus c. So x plus or minus some coefficient is going to break down into its standard quadratic form when it is squared. And the way we do that is we have to, for the c value in this case, it's going to be half of our b value. So we have our standard form, y equals x squared plus 6x minus 6. So let's set that equal to 0. So x squared plus 6x minus 6 is equal to 0. To complete the square, let's move the negative 6 on the right side of the equation. So now we have x squared plus 6x is equal to 6. Now, let's take half of our b value. Our b value is equal to 6. So if our b value is equal to 6, we need to find half that. So half of 6 is going to be 3. So now, we're going to add a new c value to our equation right here on both sides in order to make the equation still equal to its previous state. So we have to do x squared plus 6x plus 3 squared. Again, we have it squared like this because when we write it, one second, if we write it as this, it makes it a lot easier for us to break it down into x plus 3 squared. And you'll notice if you do this using the FOIL method, what you're going to get is you're going to get x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9, which is x squared plus 6x plus 3 squared. And that ties back into why we do it the way we do it. We have it written like this squared so that we know that that number should equal that c number when we break it into a perfect square. But we're not done yet. What we have to do now is we added that 3 squared on the right side to keep it balanced. And now what we have to do is we have to solve it as x plus 3 squared is equal to 15, because 6 plus 9 would make 15. Alright, but this doesn't help us in the format it is right now. So what we need to do is we need to square root it to get rid of this square. We need to square root on both sides. So this square root gets rid of that square. So now we're left with x plus 3 is going to be equal to plus or minus the square root of 15. Because we square rooted it, we need to have that plus or minus value to show that it could be either or. Because a negative number squared is a positive number, and a positive number squared is still a positive number. So now we have x plus 3 is equal to plus or minus the square root of 15, and we're almost there. What we need to do is you need to get rid of this 3 on the left side. So now we're going to be left with x is equal to negative 3 plus or minus the square root of 15. And that's going to be our answer for number 1. And make sure you keep that plus and minus still there, because we always have two solutions for this. Alrighty, so let's go into the next problem. Alright, let's go into problem 7. And this problem doesn't actually need you to solve by using the square because of the way it's laid out already. So this equation for number 7 is written in the standard form of ax squared plus bx plus c. So when we factorize to find the roots of a standardized quadratic equation, we take the c value, in this case 30, that's our c value, and we break it into factors such that the factors of c are factors of c when added. Whoops. Are equal to b. And what do I mean by this? Well, if we take a look at what b is, right? b is equal to 13. So we need to find factors of c that when added make 13. And this is a very, very simple case. So we know that 10 times 3 is equal to 30. But 10 plus 3 is equal to 13, which is equal to our b value. So, because of this, we can safely factor this standard equation into its constituent parts, which would make it x plus 10 times x plus 3. And if we break this down, xx is going to make x squared. So that's the first. Outside, x plus 3, 3x. Inside is going to be plus 10x, 10 times x. And then the last is going to be the 10 times the 3, which is going to give us 30. And we can see if we combine like terms, we get the exact same equation as we ran up there before. So that's to verify that we did it right. And now we need to get our solution. And our solution is right here with the roots. So we have to solve x plus 10 plus 10 for 0. That makes x equal to negative 10 for one solution. And the other one, x plus 3 equals 0. Well, if we subtract 3 on both sides, we're going to get x is equal to negative 3. So those are our two solutions for problem number 7. So there's two ways of factorizing quadratics. For some quadratics, they're easy to break down by using the concept of the factors of c must be added to b. And in other aspects, we have to take our b value by half and make it to our c value squared. Just like we did with problem number 1. We saw that our b value was 6. We did it Oh, I wrote that a little bit wrong. There we go. So our b value in half squared is going to be equal to our c value squared. Or no, sorry. Let's see what this is. So in our case, no, I did that right. Yeah. So in our case, our b value was 6. We divided it in half to make it 3. That means our c had to be 3 squared in order to complete that square and make it so where we could just have it written as x plus 3 squared. And then solve with the remainder of the radical using plus or minus because we square rooted both sides of the equation.